Problem number 2. You need to move a 1029 Newton sofa to the left to a different direction in the room. It takes a force of 102 newtons to start it moving. What is the coefficient of static friction between the sofa and the carpet? What is the force of static friction? Okay, so once again, what is our free body diagram going to look like here? Hopefully by now you're saying this and this over here. Okay, so we're going to be moving it to the sofa to the left. Does it indicate here whether or not we're going to be pushing or pulling the object? No, but you know what? It really doesn't matter. We do know that we're going to be having to exert a force on the object, right? You need to move this. It takes a force of this to start moving. Okay, so we are going to be applying a force onto the object, and I know that I'm giving this away right now, but we should know by now that this is what's happening here. We're applying a force onto the object, and there's going to be a certain amount of friction going on here. Now, what is the type of friction that we're going to be dealing with? Is it going to be static or kinetic? Well, it looks like that we're just trying to see how much, so we're going to be applying a certain force to actually get it to start moving. It looks like that we're really going to be dealing with it at its rest state and then trying to get it to move. So I would actually say that this is dealing with a static friction. We're trying to get this object to move. Okay, so we have our free body diagram over here. Hopefully you're comfortable with this by now. If not, go into the previous section and work on this. Okay, and what does this 1029 Newton force represent? You need to move a 1029 Newton sofa. Hey, you know what? That's referring to the weight of the object. I know that that's not really overly clear, but when you're referring to, so say if I actually have a 5 kilogram box or that's referring to the mass. And we're saying here we have a 1029 Newton sofa. Hey, you know what? That's clearly representing the force due to gravity acting on the object, which is the weight of the object. 1029 newtons. Okay. We know that we're moving it to the left. It takes a force of this to start to move. Hey, what does this 102 newtons represent? It takes a force of this to get it to start to move. Hey, that kind of sounds like the force that we're applying onto the object. And it's asking, what is the coefficient of static friction between the sofa and the carpet? Okay, so what is the coefficient of static friction? Do you remember what that symbol looks like? That mu? And it looks like that we're looking for mu s. That's going to be the first thing we're looking for. And it's asking us, what is the force of static friction? Okay, so it looks like that we're trying to figure out two things here. Okay, so we pulled out all of our given information. Oh, wait a minute. Is this object moving? No, right? Hey, what's another thing that we could pull out right now? What would you say that the acceleration is in the x direction if the object is not moving? All right, and we have all of our information right now. So, other thing that we want to do is we do have the force due to gravity, and we could find out what the mass is. All right, so we have the force due to gravity is our 1029. So we have 105 kilograms is equal to our mass. Next thing, what is going to be our positive directions? So we could say that all the forces acting upwards are going to be positive, and all the forces acting in which direction is going to be positive in the x-axis. Well, we know that we're going to be moving the object to the left. So therefore, we're going to say that all the forces acting to the left are going to be positive. So, and this is going to relate to our sum of the forces in the y direction is equal to mass times the acceleration in the y direction, and sum of the forces in the x direction is equal to the mass times the acceleration in the x direction. Hey, once again, what is our acceleration in the y direction? Is it moving up or down at all? No. And what is the force in the x direction? I'm sorry, what is acceleration in the x direction? Well, we already said that being that's not moving, that our acceleration in the x direction is going to be 0. Okay, and coming over here, what are all the forces pointing upwards? Well, the normal force, right? So that's going to be a positive force. And what are all the forces? Are there any other forces moving upwards? No. What about all the forces going downwards? Well, our force due to gravity. So that's going to be a negative force. And we know that 0 times any number is also going to equal to 0. Okay, coming over to here to the some of the forces in the x direction. All the forces to the left are going to be positive. So what are the forces acting to the left? Our applied force. Are there any other forces acting to the left? No. And then what are all the forces acting to the right? Our frictional force. So therefore, that's going to be our negative force. And 0 times any number is equal to 0. And we are currently done with this problem. We'll come back to it later on.